Hello, everyone. So let's try to start up our mini lab activity about uniform circular motion. So the first thing we're going to do is we are going to copy the table. So just select everything, Control C, and let's paste that into an Excel file. So I have an Excel file open, Control V, and here we have all our, we don't have to worry about the formatting for now, it's just so that we can collect data. We can even save it just to make sure. Um, I save it under my labs, and so this is UCM data. All right. As you can see, I try to organize my information on the same folder for all the same types of activities. All right. So we've taken care of it. Now we go to our activity again. And at this point, once we read all the instructions very carefully, all right, we open the video. So it opens on a separate video player. So again, either click here, motion of circle, or on the picture. So I'm clicking on the picture. Here is the video. So we'll start from radius 1. All right. We can even put a stopwatch, and we can go with 200 and we can go with 240 frames per second. All right, and we have to keep that in mind. It says even here on the clock, actually. And we can rewind it, and we can start playing it. So if you want, as soon as you are right here, you see, this is the mass. This is the one we're interested in. We're right at the meter stick, if you will. We set the time to 0, right? Because if you recall, our data says that we have to do the starting frame, record the starting frame and an ending frame, and the average period, right? You can even record the average period right away. So the starting frame is 0, all right? And then we're going to do the ending frame for 5. So let's record the radius. So the radius is right here, which is about 13 centimeters. So we write the radius is 13 centimeters, but we have to put in meters, so it's 0.13. Let's do the reading on the scale as well. So the scale is up here, so it's about 1.5, 1.7, right? It's closer to the half than to the 2, so it's 1.7. That's going to be part of your error discussion, by the way, the for spring scale, right? So 1.7, starting frame 0, and now we do 5 revolutions, right? So we go back to our and we start, all right? So we have, and you can see the frames here. We have the time, by the way, so we don't really need the frames. So if you will, you can just stop it again here. So it looks like it's 1.28333 seconds, okay? So I'm writing it down, 1.28333 seconds. However, let's see if we get, because it says get the average, we can do this for 5 frames, and then we'll finish. So here we have it for 5 frames. For 5 revolutions, and from frame 0 went to frame 1513. So 1513. Let's double check it because I'm not sure. It's 1513. We also have the time, by the way, which is 6.30417. 6.30417. But however, we can do the calculations for the period. So the period was, if you do the calculation, is 1 or we can do it with calculations. We can do this, with brackets. We open bracket, we have ending frame minus initial frame divided by 240 frames per second. And we get, divided by 5. And there is your average period. Now, the average speed is going to be circumference divided by period, right? So it's going to be 2 times math by pi, right? It says it written pi times the radius, and that's the circumference divided by pi, and there is your average. Sorry, one more time is I'll write it again. So it's equal to 2 times pi. It's like a function that I was doing wrong before, times the radius, so 2 pi r, divided by the period, and here is your velocity, average speed, sorry. Now, of course, this one, our information has 2 significant digits, so we're going to round this to 2. And so now we have 0.65. All right, so we have the radius, we have the speed. Now we can find the acceleration, which is velocity squared divided by the radius. All right, so the acceleration is 3.25 meters per second squared. And that is how you're going to fill all the rest of the table. So for the next one, you're going to go to radius at 2, and then you're going to repeat that process all over again. All right.